Well, that's the look of early summer. Some fair weather cumulus and cirrus. Those look like the kinds of dense sheaves that you see originating from thunderstorms. You start out with thunderstorms during the afternoon and evening hours, and then overnight these cirrus clouds advect wherever the wind blows them, and gradually they evaporate. Well, catching up here after a break yesterday. Still trying to finish that special video, and I'll have that out as soon as possible. There's just not enough hours in the day. Anyway, we got a frontal system working through Missouri into Illinois, and there's the cold front along the trailing edge. Looks like it's passing through Shreveport and around the San Antonio area there. And we do have a small complex of storms in the southern hill country, right around Kerrville, Fredericksburg, and Bandera. That stuff is moving to the southeast, and there is a severe thunderstorm watch. And we do have an area of showers and weak thunderstorms from the UP of Michigan all the way down to southeastern Kansas. And this is how it looks at this hour on the Kansas City radar. Nothing particularly strong. It looks like the heavier elements are out to the east. And it's definitely got that popcorn appearance. Highest tops on that stuff in central Missouri, about 30,000 feet. A couple points of interest. It's getting very hot out there in the southwest. We're seeing temperatures approaching 110 there at Phoenix. Not quite there, but almost. 104 at Indian Springs, and even 90s out in the higher desert areas. Even 96 in northern Nevada. So that's definitely some very warm air. Looks like the northern extent of that warm air is all the way up to Washington. Inland we got 86 west to Spokane, and even 70s in southern British Columbia. Another region where it's really hot is the northeastern U.S. Take a look up here. We've got almost 90 degrees in northern Maine, and we do have 90 in northern New Brunswick, and in Quebec also. So that's definitely some very hot air, and that's the maritime tropical air flowing north, south of that warm front. And about the only place where we have cool air is in the central U.S. The polar regions are continuing to try to push cold air southward. Got 27 there at Churchill in northern Manitoba, and 30s and 40s coming southward towards Lake Superior. And just taking a quick peek way up north, 1032 millibaro high up there in Northwest Territories. So yeah, there's probably a chunk of cold air heading south. This time of year, I would not expect that to get very far. Well, not much surprise, not much to see on the SPC Outlook. And it's interesting, if you go back and look at all the outlooks going back to March, we haven't had much of anything on the Great Plains. A lot of the enhanced and moderate risks have been on the periphery of the Great Plains, places like the Midwest, the southeast U.S., and southern Texas. So I can imagine for those who are chasing, it's probably quite a disappointing year. However, it's not quite over. It's still not June yet. Typically in the first half of June, we usually see a window of severe weather in Texas, Oklahoma, or Kansas before things start shifting up into Colorado, Nebraska, and the Dakotas. Is there anything on the horizon? Well, we can take a look at the upper air charts, and this comes from tropicaltidbits.com. It's a great website for model graphics. So starting out, we see a couple of cutoff lows, one over Arkansas, another off the California coast, and there's that belt of prevailing westerlies driving the jet stream from the northern Pacific out across Canada. Moving forward, it looks like that cutoff low opens up over California, so a little bit of unsettled weather there. Big ridge holding across the central U.S., so it's going to keep things kind of stagnant down on the southern plains, and you can see the wind flow down there kind of weak. So we're at about Monday after this weekend. Ridge is still holding on, The only chance of organized storms is going to be in the northern plains. Now we've got this new low out in California, starting to approach the Rockies, increasing the flow. You can see the flow picking up there. This is going to be late next week, around the 4th or 5th. And most of that energy goes up into the central and northern plains. And still, the flow is pretty weak down in Texas, 10 to 20 knots. Then going forward, we have a new trough working on shore there. You can see the jet advancing inland. This is going to be the weekend after this one, around June 7th. And there comes that strong flow, so it looks unsettled in California and Nevada and out into the Rockies also. But once again, the energy goes mostly north. So best chance for organized storms, Denver, Nebraska, the Dakotas. Ridge continues holding across the southern plains out to the Appalachians, so it's going to be warm and summer-like in the southeastern third of the country. And a little fast flow picking up around the 10th of June. And so that's probably a chance of storms there in Kansas, maybe the dry line, possibly starting to get going with that 25-knot flow there in the panhandles. So that's an outside chance of maybe some storms. In fact, I'd say probably a decent chance. A lot of that energy drifts eastward along the I-70, I-80 corridor. The ridge builds back in, kind of gets rooted out to the west this time. You can see that northerly flow across Texas. This kind of pattern, this can help bring some of that activity southward. When you have the tropospheric flow like that out of the north, the outflow boundaries, the storm complexes, they tend to drift southward. So that can be a kind of a cool, unsettled pattern. And I think we're pretty much at the end of the model. So it looks like we've already kicked things into early summer. Then looking at the surface fields in the U.S., got the isobars there. Looks like another little outbreak of cold air coming southward. This is going to be very weak polar air around the 29th. Yeah, and that's that little polar high being dislodged out of the Northwest Territories coming south. And that's going to kind of clear out a lot of the moisture there and shut down the Gulf. You can see the winds are kind of out of the east-northeast down there on the Gulf Coast. So we're at the 31st, and high just kind of takes its time, sinking southeastward, and the Gulf really doesn't start opening up until about the 3rd or 4th. And there's the moisture coming up once again. We get back into that active pattern on the high plains, maybe a few storms starting to get going around the 2nd or 3rd in Kansas. And then the next big change, well, got to go pretty far forward for that. Looks like a Pacific system coming from the northwest states around the 10th. There's a leading edge of that air mass, and that pushes us down into Texas. This is getting pretty far out, but it looks like the possibility of another cold front passage around the 11th or 12th. And that's about it from what I can see. And why not take a look at some of the products available on the tropicaltidbits.com site. We've got 4 different categories here: precip, lower dynamics, upper dynamics, and thermodynamics. Let's look at some of the ones that are pretty useful for this time of year. So the first one we'll start out with is radar. I mean, that's obviously useful. Shows you what your radar should be showing, and that gives you some information what's going on offshore. Also, we've got sea level pressure and precipitable water. So you can use this to kind of find your fronts and find the distribution of the water vapor field. And this is a summit of water vapor extending from the surface on up to the top of the atmosphere. So it shows you your total available moisture. So you can see that tropical plume coming up into the eastern U.S. this afternoon, and it kind of identifies your air masses. And likewise, we can see dry air coming down from Canada. Now, another form that we can look at is Anomaly for precipitable water. So it's kind of the same as the last chart, but it's showing where the precipitable water is above or below normal. Here's below normal, here's above normal. So definitely a bit humid there in Quebec and Ontario, and unusually dry in the Dakotas. And it looks like a lot of moisture has infiltrated the Central Rockies, more than we usually see this time of year. What else do we got here? 2 meter dew point. That's definitely good for severe weather forecasting. So that's also showing your moisture, except we're looking just at the surface conditions. So that can help you find your severe weather outbreaks. Then we get into the dynamics. 700 and 850 temperature advection, that's pretty self-explanatory. Now the 700 millibar temperature this time of year, that can help you find your cap. Capped air masses will show up as thermal ridges, kind of like what you see right here. The solid lines that we see here, those are isotherms. Now we're not going to worry too much about temperature advection. For one, the field is a little bit noisy, and second, this time of year we're not too concerned with advection because the effects of convection tend to dominate advective effects. That's not so much true up north, but down in the most of the U.S., things are very convective driven. And it's only your larger scale synoptic systems that tend to be driven by advective effects. And then you can also use that frontogenesis term here. It's shown as the purple lines here that'll kind of show you where convergence of temperature gradients are coming together, and that can help strengthen your frontal boundaries. The 850 millibar temperature advection chart, you can see it's blocked a little bit by the Rockies since that's intersecting the ground there. But, you know, the isotherms here, this can help you find your fronts. For example, that right there, that's going to be a 850 millibar cold front. And we can find the 850 millibar warm front right there. So that'll give you a little bit of vertical consistency in your analysis. (700 millibar vorticity and wind, 850, that's probably good for finding mesoscale systems embedded in the flow. Small scale subsynoptic disturbances. It can help identify boundaries, and that right there, I would probably consider that the cold front coming south. Sea level pressure and 10 millibar wind, that's pretty self-explanatory. You can see the difference in the wind directions marking the front there. Sea level pressure anomaly, that's interesting. I guess your blues are going to be below normal pressure. Your reds are going to be above normal. So when you're dealing with a lot of semi-permanent lows and highs like in the desert southwest, that might tell you where things are a little bit unusual. For example, the San Joaquin Valley looks like pressures are pretty far below normal. And that would indicate maybe there's been a shift in that heat low into California. It's not so much useful for areas where there's migratory weather systems like in Canada. Let's see. Upper dynamics, 250 millibar wind. That's going to find your jet streams. That right there, you can find your jet streaks also. And find the centers of your upper level highs and ridges. (500 millibar height anomaly). Again, I'm not too sure that that's very useful. That would be more useful for areas where there are semi-permanent lows and highs, like the Icelandic low, the lows off the coast of Siberia, that kind of thing. 500 millibar anomaly, I don't think that's going to be all that useful. Certainly marks out the locations of your ridges and troughs. 500 millibar height vorticity in wind. Yeah, that's definitely useful. Vorticity marks your shortwave troughs. You can find those. And those will produce a lot of your weather down at the surface. Those mark areas where the flow is departed from geostrophic balance and you're getting vertical motions as a result. Out ahead of it, you're getting lift. And behind it, you're tending to get subsidence. Also got 500 millibar heights and mean sea level pressure. I guess that's probably not all that useful. It just kind of identifies where your upper level ridges are against the surface pressure field. Thermodynamics. 700 millibar temperature, wind, and sea level pressure. Yeah, again, this is probably good for finding your caps. The cap, of course, does cover Texas and Oklahoma early in the spring, and then we see that kind of shifting north into the northern plains towards the summer. So I would expect probably later on this summer, or actually maybe later on in the next couple of weeks, we might see that cap start building in, especially with those temperatures coming up there in Arizona. 850 millibar temperature and wind, that's going to be useful for finding your fronts at 850. 850 millibar temperature anomaly, that's good for finding your air masses and reducing the diurnal effects. So we can see that the air mass is colder than normal across Arkansas and Oklahoma there, and we can see that second shot of polar air coming south. 2 meter temperature shaded. Yeah, that's just your temperatures at the surface. Contours, another way of displaying that. And then 2 millibar temperature anomaly. That's good for finding your air masses, but it is going to be more subject to diurnal effects. So if you animate that, you're going to see it kind of pulsing. Yeah, you see up here in Ontario, it's blue, then it's purple, and then it's blue, and then it's purple. That's kind of the oscillation of that diurnal effect. So you can use the 850 millibar anomaly to kind of smooth that out just a little bit. It's a little bit more consistent. You can see that right there. Okay, that's our walkthrough of most of the Tropical Tidbits model products. Okay, one last look around the U.S. You can see those storms in Louisiana and off the Gulf Coast there. Showers in the Midwest, not very strong at all. And then we got that dry air coming into the Dakotas. And there's a look at Texas with that thunderstorm blowing up there in the southern hill country. Looks like that is passing San Antonio at this time and moving south of US 90 into the Del Rio area. And there's a look at the convection out there in the southern Midwest. Definitely looks uncapped, just storms and showers everywhere. Most of the anvil is being lofted towards the northeast, but out to the west you can see some of that northerly flow starting to approach the region. And these cells out here, they don't look very well sheared. You can see the anvils barely exit those storms. So probably not a whole lot of severe weather with those. Okay, that's about all I got for this evening. I better get this edited and uploaded so we don't miss another day here. Thank you for watching. I appreciate your support, and we will see you all tomorrow. Bye-bye.